chemistry class. Right. So before we start the class, before we start the lesson, there are a few things that you need to know about the class and certain procedures you need to follow. Right. First thing is for those who have joined online. So I hope you all can hear me clearly. Right. So I'll be using two accounts during the lesson, and so initially during the class, before the class, I will send a message. So all your responses you can send to that account, because there are two accounts. So I'll be using two accounts. So to the account Jonathan Shehan 2, you can send any responses and messages. Right, that's the first thing. And so today we will give you a tute. I think they are printing it now. They will bring it soon. And we will be emailing you the tute. So you can download, and if you're joining from online, you can download and print it and keep it and write down the notes, everything as I write down on my iPad. Right. And also, so to make things very convenient and to communicate with you all, we have made a WhatsApp group. Right. So what you can do is you can, after the class today, you can send me a message. So when you send the message, you can mention your name and also the batch, that is O-level Cambridge 2024. Because otherwise I wouldn't know. Because we have A-level, O-level, we have Cambridge, NXL 2023, 2024. Lots of possibilities are there, so I wouldn't know. So therefore, you have to mention that you are joining Cambridge O-level 2024, because in this class we have only Cambridge students, and there's a separate class for NXL. Right. So your name, your batch is compulsory, and then also you can mention your school, and if you are doing privately, you can mention that. So I have an idea of you. Right. So I will add you to the WhatsApp group, and then why it's important is because now let's say you miss next week's class, right? So you're missing next week's class, but since we are recording the class, since we are recording the class, you are able to watch the recording before the next class. So let's say now if someone is missing today's class, right? So within 24 hours, you need to send a message in the WhatsApp group. I will send you the format with your name and the time of the class with the date. So your request, you can send it in the WhatsApp group. Right. So that is, if you miss the class, you're going to send the request in the WhatsApp group. I will send the format in the WhatsApp group once I add everyone to the WhatsApp group. So you need to be in the WhatsApp group. Therefore, you need to send me a message today. My number is there in the tute, you can see. Right. So if you miss a class within 24 hours of that class, you can send a request in the WhatsApp group. And my assistant is there in the WhatsApp group. So my assistant will see the message, and by next day, you will get the link for the recording. So you can watch the recording, write down the notes, you can pause the video if you won't write down anything. If you think you need to fast forward, you can fast forward, you can do anything, right? So you won't be missing any lesson in that case. But the thing is, now let's say you miss today's class, and after like 2 months you said me, sir, can I have the recording of the first class? We can't do that, right? Because it's too long. Because we have to delete the videos to keep the space in the cloud. All these videos getting stored into the cloud, and we have to keep our storage empty for other videos to get recorded. So therefore, we maintain like 1 month recording will be there, but not more than that. Therefore, you have to follow that procedure. It's not very complex. I'll send a message in the WhatsApp group as well. And right. So we will start today's lesson. How many have any of you all joined our grade 8 class? We had a grade 8 session. No, you haven't. Right. So we initially we had a grade session for grade 8 students. That was long time back. That is before May. It was a free session. We discussed some of the important things that you need in the grade 9 class. But anyway, we are starting fresh, right? And I want to tell you something before we start. Now, since you have selected chemistry, since you have selected science, so you have to be passionate about that, right? You have to be passionate about that. Don't think science is difficult. This is very hard. That is very hard. Oh my God, physics is very hard. Chemistry is very difficult to understand. No. Now, if you think like that, then it will be definitely difficult. Now, the way I'm going to teach you all is to properly understand and logically think of the answers and find the correct answers for each question, right? Can you pass this? Yeah. Yeah.
So I don't think I need.
So you write like this. Yeah. You will write if you are in the class.
So you mean I should take a little bit from
Yeah. Right. Okay. So therefore now we will be doing experiment as well. So next week we are going to do a small experiment from today's lesson. So like that, there are certain lessons where we can do some experiment. Now, what happened in the previous year was we couldn't do many experiments with the students because we had this corona problem. All these nonsense were there, like fuel problem. So most of the students couldn't come to the class. Most of them joined online. So therefore, we couldn't do like many experiments. But I'm very excited now because now students can come to the class and we can do the experiment. Now there are students who are joining not from Sri Lanka, so they will be able to watch these experiments and also learn through that. Because most of these lessons are very they are connected to practical, so it's better to do the experiment and get the experience. So that way, I like to teach all through the practicals rather than always teaching through theory, right? So today's lesson is important. We are going to look at states of matter. Right, this is something we are very familiar, not something really different, right? States of matter. So we have 3 states of matter, right? How many of you remember? So there's solid state, right? We have solid, right? You have an idea what a solid is. So we have solid state, we have the liquid state, and the gaseous state. Best example we can take is we can take water. So water in liquid state, everyone has seen. I'm missing my water bottle, unfortunately. Right. So water in liquid state you have seen, right? And water in solid state we call it what? Ice, right? So then water in gaseous state we call it steam or water vapor, right? So steam is water in gaseous state. Now you have seen this at home, definitely, right? There's ice in the fridge and you drink liquid water, and sometimes when you make some tea, you can see the steam going on, right? So those are the 3 different physical states that we learn. But remember, other than that, there are a few more physical states. But in this level, even in the A level, we don't discuss about these other physical states. So if you are interested, you can check that and learn about that. But not real necessary in this level. So I'm not going to discuss about that. Now we will look at the arrangement of particles in these physical states. Now that is really important, right? So if you take a solid state, right? So in solid state, particles, they have a regular arrangement. They have a particular arrangement, and the particles are very close to each other. They are not very far, right? So in this example, let's say we have taken a certain compound like iodine. Iodine is I2. So I2 molecules combine together like this in a regular pattern. So you can see that's a regular pattern, right? So they have a nice arrangement and they are very close to each other. But in liquid state, it's slightly different. particles are a bit random. They're not like very close to each other, and there's no like particular arrangement in liquid state compared to solid state. Now, if you look at the gaseous state, in gaseous state, particles are more random, further away from each other. Now see, between the particles, there are attractions. Now take two clay balls, right? So you can like stick them together, right? So there is attraction even between the clay balls, right? So these particles, they have different types of attraction, which you will learn in A-level class. So, but we have to know that between particles, there are attractions, right? Now in solid state, there are attractions between particles. In liquid state also there are attractions. In gaseous state also there are attractions. But what do you think, guys? In which state the attractions are stronger? Solid. Not in gas, right? Not in liquid. Why do you say the attractions are stronger in solid state? Okay. Because the particles are very close to each other, right? When you're close to each other, you can make strong bonds. Now, imagine when there was online classes, you are not meeting your friend, right? So the distance is so much, so the attraction is less, right? So your friendship is not that strong. But when you go to the school, you meet your friend every day, you're close to your friend, and the attraction is going to be strong. So like that, the particles will have strong attraction in the solid state. And in liquid state, there are attractions, but shall we compare the attractions in the liquid state and the gaseous state? In which state the attractions are stronger? Liquid or gas? Liquid. Because in liquid state, particles are still little bit closer to each other. So therefore, in liquid state, there will be a stronger attraction, but in gaseous state, the attractions are very weak, right? So you can see the diagram I have given. So liquid, solid, liquid, and gaseous state. And also at the end, I have given there's another state also called plasma, and there's another one that is found, but we are not going to discuss about it. But we will be discussing mostly about solid, liquid, and gaseous state. Right. Right. So how many of you don't have it? Right. Okay, now you have the tube, right, everyone? Right, now we're going to look at and discuss about solids. Now, solids, do they have a certain volume? Like, you know, you take a solid, does this have volume? It has, right? It has a volume. It's a fixed volume, right? So it doesn't change, right? So it has a fixed volume. So even if I put this solid into a container, so I put this solid. This is a solid, right? It's not like one compound, but it's still a solid. So if I put this solid into a container, still the volume of the solid is not changed because it doesn't change the shape, right? The volume of the solid is not changed. So I have a container, but the volume of the solid is still same. So it has a fixed volume, it has a fixed shape, and also it has a fixed volume, right? So that's about solid. So we will write down here. Right. Before we write down, let's underline all the important things here. Right. In solid state, particles are arranged in a regular pattern. Particles are arranged in a regular pattern. There's a nice arrangement in particles. So we call that lattice. Lattice is the term we use when the particles are arranged in a regular pattern. So we have these solids arranged in lattice. And between the particles, there are strong forces. Highlight that. Strong forces. Keep the particles together, therefore the particles cannot move, but they can only vibrate. So in solid state, particles can't move wherever they move, but they are only simply vibrating. So they can't move, but they are simply vibrating. So solids, do they have volume? Yes. Right, examples of solid. Now, when it comes to examples of solid, now let's look at chemical compounds. Because we are learning chemistry now. So since we are learning chemistry, let's look at some examples of solid to chemical compound. Now, how many of us have seen table salt? Table salt? You haven't seen? Huh? Table salt that you put to food, make it tasty, right? What's the color of table salt? White, right? If you haven't seen today, go home and check, but don't get scolded by your mother, right? So sodium chloride is solid, right? It's stable salt is sodium chloride. So we can write down the chemical formula for sodium chloride is NaCl. Yeah, you need to print the tube and write down. If you have an iPad or something, you can write it on the PDF. That's fine. Or if you are another way, because anyway you will have to write down these notes. Especially when we do calculation, you can't type. So you need to do diagrams. So either you need to have an iPad or you need to print the tube and write it on the tube. Right. So sodium chloride. So this is the chemical formula. So don't try to memorize the chemical formula of sodium chloride. It's going to be automatically remembered. You don't have to put extra effort. Only thing is now there are different ways of writing. Yeah, so you need to print in advance. Yes. Right. And when we write NaCl, because it's solid, we put S like this, subscript S because it's solid. This S is because sodium chloride is solid. So Na, capital N, simple A. You know the symbols of these elements, right? Some of the symbols. I hope you have studied about them roughly. Chlorine, Cl. So sodium chloride is NaCl, and we put S to symbolize solid. Now, have you heard about graphite? Graphite, you have it pencil mixed with other substance. Graphite, have you heard about diamond? Diamond is very expensive. Are you interested in diamond? Yeah, some are interested. Right, diamond is actually made from carbon. So another example for solid, carbon solid. So we put CS. So carbon can be seen in solid state. Right, now I'm going to give you another example. What is that? You know this one. H2O solid. Ice. You know H2O is water, right? Have you heard? H2O is water? Yes. So H2O solid means ice. Right. Then we have. Right. Now, how many of you have seen this? Dry ice. Dry ice. Where do you see dry ice usually? At okay. Have you seen in at weddings? Have you seen like when they pour champagne, just like white smoke comes out and like a big drama, right? So that's because they pour champagne onto dry ice. Dry ice is carbon dioxide in solid state, right? So dry ice. This is carbon dioxide in solid state. So you put CO2, carbon dioxide is CO2, and you put S again because it's in solid state. I'm going to give another example. Usually, you don't see this example in many textbooks, but we have this in experiments. So, iodine, another solid, I2. Iodine? Iodine is an element, so I2 is 2 atoms of iodine. Right, now I gave dry ice and iodine because next day we will do an experiment with dry ice and iodine. So today I'm going to anyway show you the experiment, and next day we can do a small experiment using dry ice and iodine. So now iodine usually at room condition it's a solid, but carbon dioxide is usually what? Gas. So this dry ice is not under usual condition. They make carbon dioxide solid using high pressure, right? So therefore, like when I bring dry ice to class, so I have to buy it. Like let's say we have the class on Tuesday, no? So I usually buy it on Monday night, like around 12. So there's a place in Peta, so go there and buy, because this dry ice, even though you keep it in the refrigerator, it's not enough. So it becomes carbon dioxide gas, and then we won't have any carbon dioxide to test or do the experiment in the classroom. So carbon dioxide is not a solid at room conditions, but it's a gas at room condition. But we can change the condition and bring the molecules of carbon dioxide closer to each other and make carbon dioxide solid. That is what we call dry ice. Let's go to the next one. Liquid. Right, now we have, I want to bring some water to the class. I think we do like this. Right, so I have a certain liquid here. Okay, I think I can. I need to be careful with my iPad. Right, guys. Now, what I want to show you all is, so I have a liquid here. So the volume reads up to around 200 milliliters. Okay. Now I want to know, it has a certain volume, right? A liquid can have a volume. Now, when I transfer it to this one, I don't think you know the name of this. This is conical flask, right? It is something we use in our experiment. Now the thing is, when I transfer this liquid into the conical flask, so the volume doesn't change. The volume should be still around 200, right? It can't change, right? So the volume of the liquid is fixed. But did you see that it takes the shape of the container? It doesn't have fixed shape, right? So in this one, it had a certain shape, and here it takes the shape of the container. Now, if I transfer it to another one, you know what this is? This is a beaker, right? So we kind of do experiments using these beakers. Now, when I transfer this to the beaker, the volume is not going to change. But it takes the shape of the container. You get it? Right? It has a fixed volume. This liquid has a fixed volume, but it takes the shape of the container. So it doesn't have a fixed shape. Solids, they have a fixed volume, fixed shape. But liquids, they have a fixed volume, but doesn't have a fixed shape. Do you agree with me? Right. Now let's not drink this. But again, what is the name of this? Conical flask. Okay, because we need to learn about these apparatus in upcoming lessons. Right. This one. This is the solution of sodium hydroxide. So it's been corrosive. So that's why I wanted to become a bit, safe with my iPad. It might damage my iPad. Right. Now we know that liquids, they have a volume, but they don't have a fixed shape. They take the shape of the container. Right. So let's go to the tutor again. Right. So liquids, they have volume. And also we can write down, they don't have a fixed shape. They take the shape of the container. Right, let's look at some of the examples of liquid. We know water liquid, H2O liquid. H2O, you can put L, simple L. This is, yeah, better practice with that. So we say, sometimes with the formula, we have to include the physical state. So in that kind of question, if you don't include the physical state, you lose 1 mark. You get only the mark for the formula. Right. You know, in periodic table, have you seen periodic table? You have heard about periodic table. Periodic table is very important because all the elements are arranged in the periodic table, so we can easily study. Now we'll go to periodic table later, but in periodic table, at room conditions, there are 2 elements which are liquids. Only 2 elements. Elements are, not mixture of atoms. Now, for an example, water here, it's not an element because it has 2 different atoms, hydrogen and oxygen. So element has only 1 type of atom. So 1 type of atom. Now, 1 element that is in liquid state in periodic table is bromine, Br2. Simple L, Br2. That's the formula of bromine liquid. We call it bromine liquid, and the formula is Br2, and we put simple L. The other one is something that you have in the thermometer. Simple. Right. You're going to vision here. Right. Mercury is Hg. This is the symbol of mercury. That's another liquid at room conditions. So those 2 are the elements that are liquids at room temperature, and there are other examples of liquids. We don't have to memorize any of these, but we have to get an idea of these liquids and some examples and their formulas. Right. Then we go to this one. Right. So we have given bromine here. So it's a liquid at room temperature, as I said, and this mercury. Now, bromine is a liquid which is very corrosive. That means it burns your skin, right? Now, when I was in my university 4th year, we had a practical exam. Now, they never give us bromine liquid directly for the experiment. because it can damage your skin and they have to take, it's a huge risk, right? Students sometimes they don't take the precautions and they go through these accidents. Now, therefore, bromine liquid was never given to us directly. It was in a bottle, brown color bottle, and no one has access to that bromine liquid directly. So what they do is they take this bromine liquid and add it to water. So the strength becomes less. You know, when you have a lime juice, right? You go home, your mother prepare lime juice, right? She loves you a lot. She put a lot of lime juice, right? And your lime juice is very strong. So what do you tell your mother? This is very strong. Decrease the strength by adding water. So when you add water, you can decrease the strength. So like that, bromine liquid is very strong, which is available in the lab. So what they do is before the experiment, they decrease the strength by adding water. Now this fellow, you know, there are teaching assistants in the university, right? They are the ones who, you know, prepare the solution and help you with any doubt. Professors are there to teach you, right? So this teaching assistant was preparing this bromine liquid solution and accidentally he had poured some bromine onto his hand. So after that, he was taken to hospital. And unfortunately, that was my 4th year, but I didn't see him at the university after that. But anyway, he was taken to hospital because it was very corrosive. Now then, after like 2 years, I saw on Facebook that he's doing his PhD. So fellow is okay. He's not dead. So you won't die anyway, right? It's going to be very painful. Now, what would have been the precaution that he could have taken in order to, you know, protect, in order to avoid these kind of accidents? Tell me, like, any precautions we must take. We must wear gloves, obviously, right? Yes. We must wear gloves. Say, yeah, we have to wear lab coat, right? So all the precautions we have to take. That's why it's really important. Yes. Safety glasses, because sometimes if bromine goes into your eyes, no vision, right? Even if you go to vision camp, no use, right? So therefore, when you handle these dangerous chemicals, right? So you need to know what kind of precautions you take. So for me, it's really important, guys, because when I ask you to do experiments, I have to be very strict, because some students, they try to drink from sodium hydroxide. Crazy fellows, right? They don't know sodium hydroxide is very corrosive. Your stomach will start burning, right? So therefore, when I do the experiments, I'm a bit strict, right? And we take like a lot of precautions. And I won't give you like very strong solutions. So we have dilute solution, very less strong solution. So even if you pour some sulfuric to your hand, it won't burn, because we are not giving concentrated sulfuric during the class. Right. Anyway, we have to take precautions. The other thing is mercury. Mercury is poisonous. Now we have experiment. Now the thing is, as chemists, we can't be scared, no, because bromine is dangerous. I'm not going to do the experiment. You can't be like that, right? You have to do the experiment. You have to take precautions. Now mercury is poisonous, right? So therefore, we need to definitely wear gloves and wear mask, everything as precaution. And you know what? The reason is we do experiments with the thermometer, right? One day, now I was doing an experiment, and we have a stirrer to stir. The solution and the thermometer to temperature. I used the thermometer to stir, and it was broken, and the mercury was released into the solution. They immediately came and removed mercury, because you can't send it into water. It's very poisonous. It's a heavy metal, and it's therefore dangerous. So when you handle mercury, you got to be very careful. Right. Now we'll go to gaseous state. Right. Now the thing is, gas, it has a volume, but it is the volume of the container, right? Now let's say I have a gas in this, but I have to seal it, right? I need to seal it. Now I manage to transfer that gas into the other container. two different containers, right? Let's say the volume of this container is, let's say for an example, 500 cm cubes, the volume of this one, okay? This is 1 liter, okay? Now we have a gas in this one first. So this has volume of 500 cm cubes. So imagine this is sealed, and if I ask what's the volume of air in this container, you say it's 500 cm cubes, because this container has volume of 500 cm, right? Then somehow I empty this container, I empty completely, right? And then I transfer this gas somehow through a delivery tube or something into this container. Now that gas will spread out. Now 500 cm cube won't be compressed under this area, and because this part is empty, but gas will definitely spread out. So it takes the volume of the container. Now you can say, sir, in this you have 1 liter volume of gas. Yeah. So gas doesn't have a constant volume. It is the volume of the container. So volume of a gas is the volume of the container, right? So if I ask you what is the volume of gas in this container, you have to know the volume of the container. Right? So, but it has to be a sealed container. So we will write down volume of the gas. Yeah, write down. You can write. You can write. Yeah, that's yours. There. Right. Volume of the gas is the volume of the container. This should be examples of gas. Yeah, example of gas. Carbon dioxide, neon, yes. Carbon dioxide is CO2. Oxygen, yes. O2 is oxygen. Neon is a gas, yes. So I put simple G in brackets because it's a gas. Someone said litro gas. The thing is, it has a gas, it has two gases. You know the names. Have you heard in news now? Propane, butane, level was big, and there was this whole gas cylinders blasting and stuff, right? So, yeah. So, methane is a gas. So, lots of gases are there. In litro gas, you have propane and butane. If you want to write down, you can write down. We will be discussing about propane and butane. Yeah, petroleum gas is that. Yeah, then someone said carbon monoxide. Let's write down that. Carbon monoxide. Monoxide. Mono means one. So this has only one oxygen. We call it carbon monoxide. This is carbon dioxide because it has two oxygens. Di, we use di when there are two. What do you know about carbon monoxide? It's poisonous, right? Very poisonous, guys. Carbon monoxide. Yeah. You know, in this vehicle exhaust, you get carbon monoxide. When you burn petrol, it releases carbon dioxide. So releasing carbon dioxide to the atmosphere is another problem. So next problem after corona will be climate changes. Have you heard? Right? Now our fellows were waiting. We didn't even think of corona, right? So one fellow predicted there will be something like corona. You know, Bill Gates, right? He said there will be a virus like this, and people are not prepared for it. Obviously, a country like Sri Lanka is definitely not prepared, right? We are like, we don't have even fuel. Like, how can we be prepared for coronavirus, right? But next one is going to be climate change. Now people are getting prepared for that. You know that, right? Some countries are changing from using petrol to electric cars, right? So they want to, because anyway, that we have to work together to reduce carbon dioxide level. Only one country can't, initiate anything. Everyone has to do everything, right? So in Sri Lanka, we are still not even thinking about it. We are trying to pay our debt and everything. So unfortunately, we can't do those stuff, right? Anyway, carbon monoxide, on the other hand, is very dangerous because it's poisonous. Okay, it's poisonous. You will learn in the biology class about carbon monoxide because in our body we have blood. In blood we have hemoglobin. Hemoglobin is the carrier for oxygen. It carries oxygen to all the places oxygen is required to cells. Okay, so what happens is carbon monoxide binds better than oxygen to hemoglobin. So oxygen can't find space. So oxygen can't be transported to cells. Ultimately, you will die. So there was a scene, a person has been killed. So he has been put into the garage and the other person has started the vehicle, right? And closed the garage gate. So what happens? The vehicle will give out carbon monoxide, carbon dioxide. Ultimately, carbon monoxide level will be high, right? Less amount of oxygen, and then that person will be dead. Now, don't go and kill people. Don't learn that. Don't tell that you learn it from the chemistry class, right? Now, anyway, I'm not asking you to kill anyone, but you have to be always careful. Carbon monoxide is really dangerous. It's poisonous. It can kill you instantaneously, right? So we have summarized things about these solids, liquids, gas. Now I'm telling you all not to study, memorize anything. We just have to discuss this stuff, right? So it's good to revise, important points, but these are like kind of common sense now. You understand these things easily because when we say solids, they have a regular pattern, right? Particles are arranged in a regular pattern in solid. So we call that lattice. Those are the things you need to highlight and revise before the class. So they have this arrangement regular pattern, and in liquids the particles are not regular, and in gaseous state they are very random. And in liquid state, in solid state, sorry, particles don't move; they vibrate only. But in liquid state, particles can move. In gaseous state, particles can move much more easily. Right. So energy of particles are very low. That's why they don't move. And in gaseous state, particles have higher energy. We'll come to that. Right. This is important. In solid state, they have a 3D structure. So the particles are arranged in a 3D structure. So you see in solid state, you always see it in a 3D structure. And there is this nice arrangement again. What do you call this nice arrangement? Regular arrangement, a lattice. So we'll be learning about different lattices. Right. Right. Now, next we will look at the kinetic particle theory. What is kinetic energy? The energy you need to move, right? So these particles, they move slowly if they don't have kinetic energy, right? So sometimes when you don't have enough energy, you move slowly. And your mother will give you Milo, you will move fast. But that's a lie, right? Milo won't give you that amount of energy. We are pretending so that mother will buy us Milo. And right. So kinetic particle theory says the kinetic energy of particles depends on the temperature. It depends on the temperature. So that means when the temperature is high, particles will move faster, right? They will move faster. So if the temperature is low, they won't move faster. They will be move close to each other, right? So that's what kinetic particle theory explained. So the kinetic energy of particles depends on the temperature. So you can say when temperature is high, kinetic energy is great. You can write down that. Right, so we will talk about the kinetic particle theory or the kinetic energy of particles. Usually we take a small break, 10-minute break. Okay. Right, so finally we have discussed that when the temperature is high, particles have more kinetic energy. So with increased temperature, the kinetic energy of particles will increase, and that means they can move fast. Right, so we can do a small question now. You can see at the bottom there's a small question. At which temperature the particles of water will have a greater kinetic energy? 20, 50, 100 or 7? Why is that? That's the highest temperature here, right? So the answer is so we can write down because when temp means temperature is greater, the kinetic energy, Ke means kinetic energy of particles will be greater. Good job. So if 100 was not given, what will be the answer? 7, right? So when temperature is greater, the kinetic energy is greater. Right, now we will go to the next part. Right, we are going to talk about the physical state changes. Right. Okay, have you heard about melting? A melting of ice, right? You have heard about melting of ice. That means ice is water solid, it becomes water liquid, right? So how does it happen actually? So now in solid state, the particles, they have a regular arrangement. Right. So let's say this is solid. Okay. Now between the particles, there are attractions. They stick to each other through these attractive forces. So when the temperature is increased, particles gain more kinetic energy. They break the attractions. Now what happens in solid, when you heat, right, now this is the solid state. So particles are only vibrating, but when you give energy by heating, particles, they start to move away from each other. And they break the regular arrangement. So now that they don't have a regular arrangement like before, there is random arrangement of particles. Right, so we were talking about melting. So in melting, we take a solid, we heat it, and the particles gain kinetic energy, particles move further apart from each other, and the solid will become liquid. So we have come to, yes, liquid state now. So you can see the particles have random arrangement. Right, so what happens again? So when you take a solid and heat it, the particles will initially vibrate further and they get more energy, then they will move further away from each other. So once the particles move further away from each other, they come to the liquid state. So this is what you call melting. So what's the opposite of melting then? Yeah, now you take a liquid, right? You cool it, right? That's what you do at home, right? So you put water into the freezer, so water liquid becomes water solid, or it will become ice. That's because when you decrease the temperature, when temperature is decreased, particle lose the kinetic energy. right? They will they can't move further apart from each other, so they will come closer to each other, and then the liquid will turn to solid when you cool. So that is what you call freezing. So again, we know when temperature is increased, kinetic energy of particles will increase. But when temperature is decreased, the kinetic energy of particles will decrease. Now, the best example is water. So water has this melting point, right? How many of you all remember the, it's okay, even if you remember, if you don't remember, it's fine. What's the melting point of water? That's boiling point. Zero. Zero, right? So ice will melt at zero, right? After zero, it will further melt, right? So melting point of water is zero. So melting point and the freezing point are same. So from zero, if you increase further, solid become liquid, right? So liquid, when you bring it to zero, liquid water, when you bring it to zero, you see ice forming, right? So this is how what happens in melting and also freezing, right? So we can draw this diagram here quickly. So you can have an idea of melting and freezing. So let's quickly draw. We are not like, we are international students, right? We are not Sri Lankan students. No? Because the Sri Lanka people are very slow, right? So if you compare Sri Lankan McDonald's with China McDonald's, our fellows are very slow. Fast food, but very slow. Right? So you're gonna be like international students. They'll be fast. This Ke is kinetic energy. Ke kinetic energy. So when you decrease the temperature, they lose the kinetic energy. So they can't like move further apart from each other. So they come closer. And the attraction will further form and it comes to the solid state. So melting and freezing, they are opposite things. Right, next we're going to look at, right, before we go to that. Right, so they have given here ice will melt at any temperature higher than zero and water will start freezing if temperature is lower than zero. So the melting point of water is, the ice is zero. Right, let's look at boiling. Boiling. You say at home, water is boiling, mom. What is boiling? What's happening? Water liquid is trying to become gas. So you see water vapor, steam coming out. Sometimes people get this, there are accidents. They try to open this kettle or something and there's a lot of steam coming out. So it can burn your skin cells. Right, so steam is water in gas state. So we have water in liquid state, or any liquid has particles arranged like this. So you heat it. So what happens? Particles gain kinetic energy. So you increase temperature, particles gain more kinetic energy. So when the particles gain kinetic energy, they can't be in one place like yours. They would run here and there, right? So particles in liquid state, they have a slight arrangement, but not very random. But in gaseous state, now they go from liquid to gaseous state because these particles now have freedom because we have increased the temperature, so they can move away further from each other. So you can see the attractions are also breaking. Particles are spreading more. So they come to gaseous state. We call this what? Liquid becoming gas is boil. Evaporation is part of that. We call it boil. Yeah. Then opposite of this, gas becoming liquid, it's condensation. So condensation is opposite of boiling. So that means gas becoming liquid is condensation. That's because when you decrease the temperature, particles lose kinetic energy, they come close to each other. Have you seen condensation? Salt. Condensation of salt. Practically, have you seen like sometimes when you go to Pizza Hut, maybe KFC, the glass has water droplets, right? So that's because the water vapor is getting condensed on this glass surface. So there are water liquid form. So when the vapor or when the gas becomes liquid, you call it condensation. But when the liquid becomes gas, you call it boiling. Right. So let me ask a question. When solid becomes liquid, but solid, melting, right? So when the liquid becomes solid, you call it freezing. So when the liquid becomes gas, we call it boiling, and when the gas becomes liquid, condensation. Yeah. Cooling. I thought C is a bracket. L is the closing of the bracket. Right. Right. Now, this is something we know, right? Cooling, boiling, and condensation, and then freezing and then melting is something that we have seen at home, right? And we have used these terms also. But there's something that we haven't actually properly seen. And that's something I want to demonstrate you all next class. Sublimation. There are cases where solid goes to gas without becoming liquid, right? Yes, and there are like good examples that we can show. So I'm going to show you one video first. Have you all finished copying, by the way? So these videos, when I share, you won't hear anything, but I explain in between, okay? Right. Now, first I will show. Right. So we can look at this example. So we're talking about sublimation. Term is sublimation. This is when solid directly become gas, right? So I want to demonstrate this experiment to you all next week. Only thing is we have to wear gloves because this dry ice is very cool, right? So it's better to always wear gloves. In previous years, we did this experiment. We had some fun also during the experiment, but not only the fun, guys. There are so many things that a student can observe during this kind of experiment. So watch this, and on the day we demonstrate this, you will understand it more. So we are going to demonstrate the sublimation of. You're going to watch a video of demonstration of sublimation of dry ice, that is carbon dioxide solid. So in this right hand side, they have this dry ice in a small beaker, and in the conical flask, do you remember that conical flask? They have hot water. So when you put dry ice, since hot water temperature is high, so the carbon dioxide particles in solid state will spread and become gas directly without becoming liquid. So that's what we're going to observe. We call this sublimation. Right. So they're going to put carbon dioxide solid into the conical flask. Look at what happens. Observe this properly. Okay? So water has a very high temperature, and you see carbon dioxide gas forming. Right. So this is called sublimation. Right, now I have a small question from this. So we call it sublimation. So sublimation is what? Solid becoming directly gas. That's sublimation. Sublimation. Okay. Remember. Now, one more question, guys. So you saw carbon dioxide gas, right? CO2 gas. Do you think carbon dioxide is heavier than air or less heavy?
Yes.
What's the video game? Okay. Just let's see. Is it heavier than air or is it lighter than? Lighter or heavy? Why is it heavy? How do you know it's heavy? Sorry. How do you know it's heavy? From the video, how do you know? It falls down, right? Imagine when you have helium balloon, it goes up, right? So there are gases which are denser than air, right? They fall down like this. There are gases which are less denser than air. They go up. So from this experiment, you can see that, right? You don't have to like memorize it. You can see carbon dioxide is a heavy gas, right? Because it flows like this. Otherwise, it would have gone out, right? So carbon dioxide gas is like that. Now we will look at another video. So we'll look at a video that I did. I'm not a videographer, but we like to record some videos and show to the students.
Why does it rise sometimes instead of melting?
Yeah, that's because instead of melting, yeah, that's because it depends on the attractions types. There are different types of attractions in between different molecules. So carbon dioxide has very weak type of attractive force. So therefore, it can directly go from solid to gas at room temperature. Even slightly higher than room temperature, it can supply. Right. Now we will go to another video. This experiment also we can do here. This is a good experiment because now we know sublimation is solid directly becoming gas. And in this one, I can show you the opposite of sublimation as well. That's why this experiment is very important. Now, solid can become directly gas. Gas also can become directly solid. So, opposite of sublimation is also there. We look at that in the video. Right. So, by the way, this is my channel. You can subscribe. Right. Its name is The Real Chemist. And obviously, you have more videos to watch related to O-level and A-level stuff. Right. It's very difficult to continually do it because of the time we have. But we have managed to put some of the videos. So this is sublimation of iodine. Now this video is very important. These videos are very important because now, for an example, in the O-level exam, sometimes they ask a question relative to carbon dioxide. And they might ask whether carbon dioxide is heavier than air. Now, since you have already seen it, you know the answer, right? And this is important because sometimes they ask, what is the color of solid iodine? What is the color of iodine gas? So that you can remember through the video. So we will look at. So we have a burner, some beakers, some iodine, that is the watch glass, the cooler. And so what we do is usually we heat the beaker. Because when the beaker is hot, there's enough temperature to increase the scientific the particles in iodine solid. Now, that's the color of iodine solid. Gray color, right? Silver in color. So, iodine solid is gray. Now look at that. Let's go to the see immediately. Now when I put iodine solid into the glass, it's hot. It's iodine solid. When I put it in glass, immediately becomes no liquid. Look at the color of the gas, iodine gas. That's the color. Purple color. Right? So this is what we call sublimation again. Now what I put is this. Now beaker is hot. Right? So iodine solid directly became gas. Now I'm using a small trick here. This is what we call a stopwatch. The watch glass here. So we have watch glass. I have kept it on the beaker. Can you see? So I covered the beaker with the watch glass and I'm putting ice. Now the watch glass is becoming colder. So the surface of the watch glass is cold. So gas will become solid again. Right? So when the beaker is hot, the solid became gas. So I can reverse that by putting some ice because any gas that touches the surface of the watch glass will become colder and then it will turn into solid. We call that deposition. Opposite of sublimation is deposition. So we will observe that here. Take the bottom of the watch glass on the right. Provide and then take the watch glass out. At the bottom of something. You see, iodine solid again. So we look at that part of the again. Thank you very much. Can you see under that watch glass, there's solid depositor, right? And that you can again down and display some iodine solid. Depositor. So gas directly becoming solid is deposition. So solid directly becoming gas is what? Sublimation. So opposite of sublimation is what? Deposition. Right. Now we will go to the tute. So we'll ask some questions after this part, right? Right, so we have talked about sublimation and deposition as well. But before that, in page number 8, let's go to page number 8, guys. Before that, can you fill here now in page number 7? Can you go back to page number 7? This should be condensation. Topic should be condensation. Since I've already discussed about condensation, then I'm going to go through this, but this will be useful when you study. Right, I'm going to do this question. Melting point. Melting point is the temperature at which the solid starts to melt, right? Melting point of nickel is 1452 Celsius. And melting point of silver is 951 Celsius. Which of these metals have strongest attraction? Nickel. That's because nickel requires very high temperature to melt. So since the attractions are strong, it requires very high melting point, very high temperature for nickel to melt. So if the melting temperature is high, that means the attractions are strong, right? The compounds with strong attractions require very high energy to break the attractive forces, right? So we can write down the answer. We can write like this. Nickel, the symbol for nickel is Ni. Nickel has higher melting point than silver, Ag. You can put the symbol silver is Ag, nickel is Ni. Because it's better to get used to symbols as well.
As a higher melting point,
Ag, silver, Ag. Ag,
no, before that.
that. Therefore, attractive forces. Therefore, the attractive forces in nickel are stronger. So if something has a higher melting point, which means the attractions are really strong. Yeah, do you understand that? Because if you have to give a lot of energy to melt something, that's because the particles have lot like strong attractions in the solid state, right? You get it? So can we do the next one? The boiling point of ethanol is 78 Celsius. State whether the attractive forces between ethanol molecules are stronger than water. Stronger or weaker? Weaker. How do you know that? Because very good. We know the boiling point of water is 100. H2O means water. So we get questions like this. Now, the thing is, in previous question, melting point of both were given. In this question, the boiling point of ethanol is given, but boiling point of water is not given. So Cambridge assumed that students know the boiling point of water, because water is something we know commonly, right? So the boiling point of water is 100. So we can say, since the boiling point of water is greater than ethanol, the attractive forces in ethanol are weaker. I think now the power K.
The active forces
In ethanol are weaker. Is it blinking? Right. Until that, you can take a pencil and complete the. Huh?
the president.
Okay. There's a diagram. There are arrows. You need to write down the correct change in physical state. That's it. This one. Right. First of all, this is solid. This is liquid, and we have gas. Right. So this arrow indicate solid is becoming liquid. That should be melting. The other arrow indicates the opposite of melting, freezing. Right, then we have the purple arrows. This one indicates liquid becoming gas. So that should be boiling. So the opposite of boiling is condensation. Right. This is solid becoming gas. We just watched the video. Sublimation. Yes. And the gas becoming solid is deposition. Sublimation. Right, have you finished copying? Right. So we watch these examples for sublimation. So that's solid becoming gas and camphor. Correct. What does it have? Lot of carbon. It melts. It doesn't. Wax also melts. It becomes liquid. Right. These are the best examples. We can demonstrate easily with these two. Right. Then I'm going to give a question. Right. Let's write down the question. Right. A substance X has boiling point of 10 Celsius. So this is the boiling point of substance X. And the melting point is of X is minus 40 Celsius. Right, so the melting point is minus 40, the boiling point is 10. Right, the question is this: what is the physical state of X? Now don't give me the answer, don't shout the answer. Just write it down, okay? And then we'll check. So what is the physical state of X at minus 20 Celsius? Right, read it clearly. So the boiling point is given, the melting point is given. They're asking what will be the physical state of X at minus 20 Celsius. So if you get an answer, you can write it down. Now, we haven't done a question like this, but I think you can think. Yeah. So the boiling point is 10 celsius. Melting point is -40. So we have to find whether it's a gas or is it a solid or liquid at -20. Right, okay. Shall check the answer? I will figure out an answer.
Yes.
Right? It's okay. Even if your answer is wrong, it's fine. Okay. But how many of you think X is a let's say X is a solid at -20? How many of you think? It's okay. Even if your answer is wrong, it's okay. No, none of you think. How many of you think that X is a liquid? Okay, some of you think. Anyone from the online group? Anyone think that X is a liquid? Okay. Right. Some students think. So how many of you think that X is a gas at -20? So some of you all are not having any answer. Not gas, not liquid, not solid. What is that physical state? Yeah. Tactic 2. What order? No answer. This side or this side? Some students, they answer, they go with the most answer, most selected answer. Now, how do you do this? First thing is, if answer this now, what is boiling point? What is boiling point? Boiling point is the point where the liquid changes to gas. Now see, I will explain this in a better way, but before that, see, so the boiling point of this X is 10 Celsius, right? So that means if you have a higher temperature than 10, it becomes a gas. Do you get it? Boiling point of X is 10, right? So that means after 10 only, X will become a gas. But -20 is not higher temperature than 10 Celsius, right? Do you understand? So X can't be a gas, right? Now melting point is same as freezing point, right? Freezing point is the point at which the liquid becomes solid. So -40 is the exact point. Anything lower than -40 will convert X to a solid. So let's see, then X is a liquid at room temperature. Now let's see about that. See guys. So this is the thinking I bought from y'all. Now we have the melting point. So melting point is 10 Celsius. So anything higher than 10, at any temperature higher than 10, it is going to be a solid. You can copy this. So any temperature higher than 10 will turn X into a solid. Sorry. It's the opposite, okay? Any temperature higher than 10, it will become a liquid. Yeah, let me mark the melting point here. Right, any temperature higher than 10. Melting point. It will turn so 10 is the boiling point. Melting point is -40. Right. any temperature higher than 10, at any temperature higher than 10, this X is going to boil. So it will turn into gas. Right, it will turn into gas. Now we have a melting point also. Melting point is less than the boiling point, it's minus 40 Celsius. So that's the melting point. So if you decrease the temperature less than minus 40, if you decrease it less than minus 40, it will become what? It will become solid. So minus 20 is in between 10 and minus 40. So in between what you have is the liquid state. So that's why at 20, minus 20, it can't be a gas, because for it to become a gas, it should be, the temperature should be greater than 10. For it to become a solid, the temperature should be less than minus 40. So at minus 20, it should be a liquid. So I'll look at another example like that. You have 7 minutes. Right, I'm going to give another question. Huh? Easy one. Easy one, no hard one. Hard one, no? Okay, let's do another one. Right. Boiling point of boiling point of Y is boiling point of Y is minus 30. And the melting point of Y is, so the melting point of Y is, it should be lower than minus that. So we will say minus 200. Oh, yeah, that's fine. That's fine. Right. So the question is, what is the physical state of Y at minus 20.5 Celsius. If you know the answer, you can raise it.
We don't know the answer, then what do you do?
Then wait until the class is done. How much shall know the answer? 1, 2, 3, 4, 5, 6. Okay. Now boiling point of water is 100. So any temperature at any temperature higher than 100, water is going to be what? Gas. Boiling point of water is 100. That means at any temperature higher than 100, water is going to be a gas. Now, what is the physical state of Y at minus 20.5? How many for not gas? What's the answer?
Yes.
Yes.
Gas. Yes, because minus 20.5 is higher than minus 30. Look at the boiling point. The boiling point is minus 30. So if you have temperature higher than minus 30, this is higher than minus 30, right? It's higher than minus 30. So that means at that temperature, compound Y should be in gaseous state because the boiling point is 30. Any temperature higher than that, it will be in gaseous state. So minus 300, let's say minus 30. So below minus 300, it will remain as a solid. Below minus 300, it will become a solid. Greater than minus 30, after the boiling point, it will turn into a gas. Minus 200, yeah. So below minus 200, it will become solid. If it is higher than minus 30, it will become a gas. In between that, it is going to be a liquid. So our temperature is minus 20, which is higher than minus 30. So minus 20 point at minus 20.5, it will remain as a gas. You get it?
Yes.
Right? So the answer is gas. Again, remember the answer is gas because the boiling point is minus 30. So that means at any temperature higher than minus 30, like this, compound Y is going to be a gas. I didn't say the class is so. Some people are packing. Right, did you understand that?
Yes.
Is it clear?
Yes, sir.
Right, so please revise everything before next day. So we will do some experiments. If you can come physically, come and join physically so you can participate. Right, have a good day, everyone. Bye bye.